Hello everyone, this is Gary from Gary's Place. This is Gary's Place. Welcome to Gary's Place. So today I'm going to be doing a video on pretty much a compilation of everything that I've done to my Sunlu S8. This is just pretty much everything to take the stock Sunlu S8 and actually make it a decent printer. I've been through a lot. Most of this stuff I already have videos on, so I'm not going to go into too much depth with a lot of it. Just going to pretty much mention it, maybe go through a quick, how to, and then just pretty much talk about everything that I've done all together as a whole to take this printer from eh to decent. So stick with me, and we'll take this trip together. All right, guys. Uh, just a minute. Okay, guys. So just going through most of my changes here. So I do have a previous video that I did about necessary upgrades. This is obviously going to be an update to that video. A lot of good stuff in that video if you want to keep everything stock. But obviously I decided to change a lot of things because I wanted a printer that would reliably print PETG, which means higher temperatures. I wanted to use larger nozzles so that I could print quicker, and this seemed to have done the job. So in my last video for the necessary upgrades, I told everybody to replace this extruder. Now, the regular red aluminum extruder that you buy, there's all sorts of them out on the market. They work great, but when you're pushing a lot of filament and, when you switch a lot of other things around, a dual gear extruder is obviously a lot better. This one I got on Amazon, it was like $15. I do have a video out on the install of this, but it's pretty simple. There's these two screws here, this long screw here, and there's a short screw underneath this arm. There is a thread cert. It took me a second to kind of figure out where that went. It sits inside the spring, and then this screw allows you to adjust the spring tension. I didn't really put a whole lot of tension on it because this is a very hefty spring, and as you can see, it slightly chews up the filament, but no more than the other one was. And I've been getting a lot more reliable, stronger push with this one. So I bought the version that had two quick connect fittings here. Okay, one on either side, because I had a little bit of a jamming problem, and I was just kind of getting sick and tired of having failed prints, so I bought this smart sensor, another Amazon buy. I got it for like 12 bucks, but I think it's like 20 normally. I got it on sale. So I printed a mount so that this would mount to the stock hole where the other filament sensor that the machine comes with went. This is a nice sturdy connection here. There is a little bit of movement, okay, when you squeeze the arm down, but you don't really have to do that very often, so I haven't found an issue with it. The plastic actually flexes pretty well to that, especially because it's only being held in with one screw. But this is a nice, tight, reliable fit. There are two screws. If you look up the GitHub on this, Big Tree Tech has a whole installation thing. It says there's two screws that you can use for mounting. You just unscrew them, and then it comes with two screws to replace them with that are slightly longer. Coming down the filament path here, I have my spool holder. This is my own design, as is the smart sensor mount. This is on my, this and the other mount are on my Thingiverse. So just look up Gary's Place on Thingiverse. You should be able to find that very easily. The only thing is about that is you will have to remove the front cover and then remove the 2 screws that hold this extrusion in. You remove the 2 screws, and then all you really got to do is pop this up. I have something that I stick underneath it to kind of hold it out because the tension of the frame wants to pop it back in. You know, just long enough to slide this in, and then you're good to go. This is a redesign because my original design just had 2 holes here. However, when I replaced my hot end, and I'll show you that in a second, I needed to bring the carriage down as far as it would go, just so it's just barely above this motor bracket. So I had to have this notch cut out just so that it wouldn't make contact with this. So if you do all of these upgrades, this will fit just perfectly. You know, it slides back and forth, so you know, if you need to slide it in out of the way, if you're doing some work up here. I would say though that if you do install this and you end up doing some work up here, I would slide it out of the way just because I have knocked this with my elbow. You know, when I'm grabbing the filament here and pulling it out, I knocked it with my elbow and broke it. It's very sturdy. I think I printed it at 70%, so I mean, it doesn't really have a whole lot of issue now. Obviously, that's like my 8th iteration of that one. So yeah, that's a good one there. I would recommend when you print that though, do tree supports. It uses a lot less support material. Takes a little bit longer, I think, but uses a lot less material. So moving on, I would make a note here. Sorry about the mess, guys. I got my little grease needle here, and obviously I got to clean out underneath my printer here. Maintenance every once in a while. I've just been really busy. So I did a video before about making sure that you get this belt adjuster straight and tight, and to make sure that it doesn't walk, otherwise you get noises. I almost want to say I would recommend replacing this bearing just because they're poor quality, and so are most of the bearings on this, but I'm waiting for them to fail before I replace them. To somebody who doesn't want to deal with that later, do it right off the bat. Get them out of the way. They're cheap. Cheap enough at least. So I upgraded mine with an all-metal hot end. This is a E3V V6 clone. Was I want to say $10, $12, something like that. I think Amazon sells them, eBay sells them. They come as a whole kit. You get a new thermistor, you get a new heater cartridge, all that good stuff. But I did have problems mounting this, so I had to design my own. So this is my mount. You can also find that on Thingiverse, and as you can see here, this is all one piece. It goes over the plate, bolts in place. Nice tight fit, and then nice tight fit around the hot end. Kind of clamps in around it. So then after I designed that, if you guys have been watching my videos, you know I did a fang. Well, the fang I was having jamming issues with constantly, just because I was running at the higher temperatures. And if you do install this E3D V6 clone, as I understand it, the E3D V6 is also the same way, where you have to limit your retractions, otherwise you're going to have jams, which is how I ended up getting the smart filament sensor, and I'll go over the wiring for that in just a minute. This dual gear extruder kind of sort of fixed that problem. It has enough oomph. I also had to tune the stepper drivers, give them a little bit more punch to, you know, kind of push through all that. So that's that. All of this is on Thingiverse. So I designed the fan mount here for this 2040 fan. So this is the stock fan that was on here. I was having a problem with jamming, but the majority of the problem was heat creep at first. Now I get an occasional jam. It doesn't hardly ever happen anymore. now that I have this set up properly, but you need enough air going past these fins, and you need to make sure that all the heat is being blown off. And this setup that I designed here does that very well. It's a straight on. However, you can see there is a very small gap in between here, so it doesn't let a lot of air go through. I mean, if I were to have designed this, I would have made these gaps a lot wider, just so that the air could flow freely through there. When this fan is on, you can kind of put your hand here, and then you can feel the air pushing back because it has too much resistance on this side, but it gets the job done. So I installed a 5015 fan for my parts cooling, designed this vent to go around it. I made it a square. Sorry, I'm a little dirty here too. I gotta clean this thing out. But I made it a square, a rectangle, because the heater block itself is a rectangle, and I figured that would kind of get the parts cooling all the way around it, but keep it as tight as possible. These holes are tilted slightly downward, so if you kind of stick your finger right here just underneath the nozzle, you can feel a nice blast of air coming all the way from all different directions. So that's been a very nice nice addition here. Okay, as you can see, I have my washer here. I accidentally cracked the little hole that this screw goes through, and there was a buzzing noise, so I put that in there to get rid of that. I will eventually be replacing this again because of that, because I don't like it. Obviously, who wants something ugly like that? But the other thing I wanted to talk about is when you get these fans, they have the stock fan little 2-pin connector. You can go on Amazon and buy the other end of the connector, because obviously the stock ones are wired into the wiring harness. I've got that here. I wish I would have purchased these before I installed that fan. Let's see if I can get a good look at it. So that's the JST XH 2.54 millimeter connectors. The kit comes with 2 connectors that are male and 2 connectors that are female, and then some little adapters. I guess they go from male to female, female to male, whatever. I wish I would have purchased that when I purchased the fans, because then I could have only soldered this in once. Unfortunately, now I'm going to have to take this apart, cut the wires, and then resolder it. Word to the wise, when you order the fans, order the connectors for them. That way, if you ever have to replace them again, you know, you can just unclip and clip. So much simpler. The smart filament sensor, you have to run wiring. It comes with a wiring loom. Okay, but the wiring loom that they give you is not long enough. Okay, so I used the 2 stock wires that were already in here as 2 of the wires. You need 3 wires. Unfortunately, the connector. So this is a 4-pin connector here, so you can't just use the connector that's already there. You're going to have to use a little screwdriver, or I found those little needle tweezers work really good for pushing those pins out. Okay, so what I did is I used the 2 wires that were already here, because they were already run to the board, and then I took the wiring loom that they sent me, took 2 wires out of it, soldered them together, and then ran them from the board up to here. Even made sure that I put them through just the same wiring loom, and as you can see, everything's all taped up here. So, and again, sorry about the mess, guys. I unfortunately have been very busy lately. I'm a creator, and you know, that doesn't really leave a whole lot of time for cleanup all the time. But so to get to the board, you have to pop this cover off here. All right, so there's 3 screws, 1, 2, 3. Okay, and then when you get those out, make sure your SD card is out, because that will stop the cover from coming off. And then I'll show you here. If you just take a screwdriver, pop it in there, just push it straight in, and then the cover will kind of lever over that USB connection there, and then you can just pop the cover off and it levers off the back. Okay, so in here we have the power supply and then we have the board. Okay, let's see if I can find my wires here. Okay, so the connector for the sensor is that one, this one here. Okay, I found it easiest to get this, I think this is one of the thermistors. I popped this out of the way so that I could access this one right behind it. And as you can see, it says DT there. That's for the filament detection. Okay, and then what you're going to have to do is pop this connector out. And then you got to change the order of the pins in here. The center is the ground. The one here on the end, all the way on that side, is the actual sensor wire. And then the one all the way on that side is the power. So you need all three of these wires for that to work. And that's pretty much how most of these are set up in here. You have power, ground, sensor, going from right to left. So you'll have to set that up, and then you'll have to set it up in the firmware, and I will show you how to do that in just a second. I wanted to talk also about the stepper drivers. You can see in here. Let's see if I can get it to focus. There we go. So each one of these heat sinks, these metal heat sinks, is a stepper driver. Okay. And as you can see here on the board, it has it listed as a A4988. Every tutorial I found about adjusting these stepper drivers says that you turn, let's see if I can get a good, come on, focus for me. Jeez, sorry guys, can't get this thing to focus. Let's see here. Okay, so this is our stepper driver here. These are built into the board, so unfortunately you cannot replace them. There's a little screw right there. Okay, every tutorial I found on tuning these stepper driver motors says that you turn that screw to the right to raise the voltage, and you turn it to the left to lower the voltage. However, these are backwards. You turn them to the left to raise the voltage, and you turn them to the right to lower the voltage. So when you do this, you need a voltmeter. You set it to 2 volts, and then you can either use your ground here, or I guess the casing of the USB is grounded. You can do either or of those. The other lead goes directly on that screw. And starting from this side, which it would be the left, I had Sunlu send me their information on it. So on the left, it's 0.65 plus or minus 0.02. The next one is supposed to be the same, 0.65 plus or minus 0.02. The third one, which is your z-axis, is supposed to be 0.57 plus or minus 0.02. And then the last one on the end there, underneath that wiring, is the extruder, and that's supposed to be 0.65 plus or minus 0.02. Now on my extruder, because I was having a slight jamming issue and I needed a little bit more oomph, I set mine just a touch high. You know, that just gives you a slight bit more tension or push, whatever you want to call it. So that's that in the board. You can also take this off by removing the LCD connector there, and then you can take this all the way out. I don't want to do that today, so I'm just going to stick this back for a moment. When I upgraded my V6, or upgraded to this V6, I had to bring the Z-axis down a little bit farther, as we talked about with this bracket. I'm sorry, spool holder. But I still wasn't able to get it to go low enough to print on the bed. So my bed has these spacers. I also have them on Thingiverse. I found 3 millimeters was just fine to get the bed where I wanted it. So I did a 1.5 millimeter on the bottom and 1.5 millimeter on the top. You can see I have two spacers there. There's a little groove there too that those springs actually sit in. I did replace these springs too because my original extruder upgrade came with a new set of springs, so I figured, hey, why not? And then the last thing I want to talk about is just making sure everything is tight. You want to make sure that you have these wheels here. There's an adjustment on that one. You want to make sure they're tight on both of them, and then on the Z, and then on the X, and then on the other Z. You want to make sure those are all tight, and generally when you get your printer, it would be a best practice to go ahead and tighten everything up, because a lot of it will be loose. You'll be surprised. Let's see. So I wanted to just go over the firmware stuff real quick. Like I said, guys, this is going to be a general video. I'm not going to go into too much depth, but I want to show you all the upgrades I did that actually made this a decent printer. And one of the main things was the firmware upgrade. I did have to change the firmware anyways so that I could add that sensor. So at the same time, I updated it, and I'll show you guys what I did there. So hold on just a second, and we'll be right back. Okay, guys, so I wanted to go over the firmware upgrade. So I tried a lot of the ones that were out there, and honestly, the TH3D version was the best that I could find. My printer has not printed better than with this particular firmware package. The guys down there seem to have done a lot of work on that, and I really greatly applaud them for the work that they've done there. Now, this will also put a TH3D logo on your printer, so when you power up, it's going to say that. They actually just updated to a 2.03, I think it is, but it's fabulous. Work they've done here, because, like I said, my printer has not worked better since I installed this. So all the other upgrades that I showed you, they made a world of difference, okay? But this, above anything, I think made a lot larger difference. And also, too, it makes it so that you can add things to your printer, because if you talk to Sunlu for their firmware, they will send you just a file that you can use in Cura to update your firmware. It's pretty much the same thing, and so all you guys have to do is do a Google search for TH 3D firmware Sunlu, and that page should pop right up. You'll download it, and then if using VS Code, if you guys haven't used this before, download it. It's very simple. You go to File, you go to Open Folder, you navigate to your folder, to this folder Firmware, which is inside the file that you download. Select folder, and then it pops up with this screen. You want to go into configuration.h. You want to undefine this if you have this board. I happen to have this board, so I undefined it. You have to define Sunlu S8. That way it knows that's what the printer you're using is. In my case, if I scroll down here, because I added that smart sensor, I have to define it here in the firmware. You can go to edit and then find, in order to find it, but I know that it's right near the bottom. Let's see, filament runout sensor. So everything should be turned on for filament runout sensor, except for you have to define this line. So you have to uncomment this line, which means delete these two little slashes, and then you have to put a 7 in here. That's explained in the GitHub for the sensor. And then you want to undefine this filament motion sensor. There'll be 2 slash marks in front of here, so you want to get rid of those, and then that way it will start looking for a filament motion sensor, which is what that is. And that's all you have to do. I know that I've watched a couple other videos, they tell you to do a lot of other things, but because the printer already had a filament runout sensor, all the rest of that stuff's already turned on in this particular setup. And then I did something a little different as well. So if we scroll, let's see, where is it? I probably should just search for it, but I guess I'm a little stubborn. So if you go into the configuration backend, which is pretty much configuration.h for like normally that would be where you'd find that in Marlin. I went to this line, and normally it would have ABS, because you know how you go to your printer and you go to preheat. I use PETG all the time. I never use ABS. Uh, so I changed that to PETG, and then I changed the temperatures to the temperatures that I personally use for my PETG, which is 230 and 80. And that gets that to have that preheat option. Okay. Okay, so one thing that I did want to note too is that if you have a custom E-steps, so say for instance you printed a calibration cube, you did the measurements, and then you found your proper E-steps. This is where you're going to put it. So you're going to want to use the search function to look for default axis stepper, and it should be easy to find, and it's kind of like right in the middle of configuration.h. I don't know if you can see that there, but it's right in the middle of it. So you would put your 4 values right there, and then when you load the firmware onto your printer, it's already there. And then you don't have to redo that. I mean, I would still say that it's probably a good idea to go ahead and reprint calibration cubes again after you have updated this, because things might change a little bit. Um, so see how that works for you. And again, those values go right here. And then scrolling down just a little bit here. Oh, I'm sorry. Scrolling up just a little bit here. We have define our K value for linear advance. Now this is automatically set to 0, which if it's at 0, that means linear advance is not active. I don't know if you guys have used linear advance before, but it really does make for a better printing experience, and it it just makes things better as far as I'm concerned. My value was about 0.05 for the K value. In order to find that value, you need to go to the marlinfw.org /tools/linear advance /kfactor.html, and then that will give you a generator for a linear advance tool that you will use to figure out what your value is. But again, my value was about 0.05. I will note that when you're on that site and you generate the G code from it, you are going to want to make sure that you change the fast printing speed. It defaults at 70. However, you know, I don't know if anybody else has realized this or not, but this printer, its max speed's about 50. You go anything higher than 50, and you're you're not going to have the greatest printing experience if you go above 50. And I have figured that out through experience. But hey, do whatever you guys want. But in this test, I would say that 50 is about as fast as you're going to want to go. So once you've gotten all that put together, and again, you can always just come back in here and change that and then re-upload the firmware. Um, when you do first download VS Code, you are going to want to make sure you get these two plugins, Platform IO and the Marlin Auto Build. So once you've gotten everything set up in here the way you want it, and again, if you have other options like a BL Touch or anything like that that you've added to the machine. I don't, so I didn't go through that, but you are going to want to enable all that stuff in here. I'm not going to go over it because I don't have it and I've never actually done that. Then you'd go over to this Marlin and then you'd hit the little hammer icon for the build. Okay, it automatically knows what board you're using because you declared it earlier. It's going to compile all this. It takes a second to compile. It's nothing major. And then once the best part about this Marlin auto build is that if you've already told it what board you have and everything else, it already knows how to compile it all. And then once it goes through all of this, come on, you're almost there. There we go. You can just hook your printer up via the USB cable and then hit upload, and it will go ahead and upload. Obviously, you're going to want to make sure your printer is on when you do that, but that's pretty much the rundown of how that works. Okay, guys, so that's pretty much that. By now, if you've purchased this printer and you've gone through this video, you went from having kind of a mediocre printer to an actual pretty decent printer with a decently large build volume, which of course is the appeal of this printer. Now, uh, I will say that I talked about how I initially installed a Fang when I put this E3D V6 on here, or I'm sorry, E3D V6 clone on here, and I was having a bunch of issues with the Fang. The sad thing is if you watch these videos, you'll know that I actually got it printing pretty well by the time I took the Fang off and was even considering leaving it on. I mean, not to talk too much junk about that, but it was a decent setup. As long as you can get a good print out of it, and you're okay with doing a little fidgeting around. But um, now, as everybody who's watched my videos knows, I generally try to do everything on the cheap. A lot of this was to show you that you can do 3D printing on the cheap. Like this printer, I believe I purchased it on sale. It was $168. And then most of the upgrades that I've purchased since then have all been also on sale. So always check out those sales when they're out there. But I believe I put an extra $50, $60 into it, with everything. So, I mean, just a little over $200, and I have a pretty decent printer that does a very large volume. Um, and I'm pretty well happy with it now. Wasn't so much before, but it is what it is. So, hope you guys enjoyed this. Please subscribe down below. Put some comments out there. I do have to let everybody know, or everybody that subscribes currently and watches my videos, that I'm probably not going to be doing a lot more of these videos. I am moving on to other projects, and I will, once I'm done with those projects, I'll probably do a video and put them on here. But unfortunately, I haven't really gotten the response that I thought I would with these videos, and they do take up a lot of my time. So, you know, if I can't reach out to a certain amount of people, and I'm happy to help the people that I have helped, but you know, if these videos aren't going to be watched and people aren't going to be, you know, learning from this, or it's not helping other people, I just assume use my time on my other projects. So, just so you guys know, you won't be seeing a whole lot from me, just some projects here and there as I finish them up. So, until next time, uh, happy printing and you know, enjoy, guys. All right, take care.